It wants you to model the billions of dollars of debt 2 years after 1965 based on the following information. Okay, so in 1965, the debt was $322.3 billion, and during the next 30 years, the increase was 10.2%. All right. So when you're looking to write this model for this piece of information, it asks you to choose it as D. And then you take your starting amount. So the starting amount is what we start with in 1965. So 322.3 is our initial amount. And we're going to multiply that by, and then the way that you find the growth factor is you basically add 1 to whatever the rate is. So our rate is 10.2. We need to convert that into decimal form. So 0.102 is our rate, and then take it to the power of t, the time. Okay, again, this is an annual calculation. And so if we simplify this even further, because we don't need the plus in there, we get the form of your answer, which is 1.102 all to the t. So this is your model. Okay, oops, so that's 52. Okay, on that one, what we're going to do is you evaluate it for 1980. Well, if t represented the number of years since 1965, then 1980 is going to be what year? You're going to let t equal 15. And so if you take this function right here and evaluate it for t equals 15, you'll get your answer for that. So again, if I take my expression here, and so you don't have to use solve feature, and I know a lot of you will use solve for everything, but you can just type in your expression if you want here. So you can type in 322.3 times the quantity 1.102 all to the power of, and again, 1980 represented a time or t value of 15. And so you can just hit enter and you get your, what did I say to round it to? Let's see, and then what was, so let's talk about this then really quickly. So 1383.516, right? All right. So when we look at this, and this is in billions, correct? All right. So if you're looking at that in terms of billions, did I put a label on there? So I asked for trillions, right? So trillions is going to move this decimal point how many places? Well, 1 trillion is 1,000 billion, right? So if we're going to go into converting this into trillion, where do we need to move the decimal? Left or right? It's a 50-50 chance of going to jail or being right. 1, 2, 3, right? 1.3835516 trillion. And so now if you do round this to the nearest 3 decimals, what does it wind up being? 1.384 trillion. The next one for this was 54, which was to estimate the year when the debt hit a specific value. Okay, so what we can do here is the given value is our D value. So we want to find T when D is equal to 2120. Okay, so easiest thing to do is to use the solve feature of your calculator and just plug in 2120 for our D value equals, take our equation, 322.3 times 1.102 to the T and solve for T. So I'm going to do that here. Is equal to, take our function, 322.3 times the quantity 1.102 all to the power of t, and we want to solve for t. And we close it off, and we get 19.39. So basically, if our t value is 19.39, we're going to add that to 1965. And really, you can just truncate this, right? This is one of those cases where the difference between truncating and rounding, and you don't need to round here because it asks you in what year this happened. So even if we had 19.8 or 19.9, it's still just going to be in the year that's 19 more than 65, right? So if we just add 1965 to 19, we get 1984. Okay, now, in this case, it winds up being about 40% of the way through 1984. Okay, but even if it had been 80 or 90% of the way through 1984, it would still be considered 84. Okay, so now I want to make that clear because it may affect answers when it's dealing with years. Is everybody clear on why you wouldn't round this? We don't need to worry about it here because it's a number that wouldn't round anyway. But if this had been 19.7, would our year have been 1984 or 1985? Still 84, right? It would just be late in the year of 1984.